Okay, now let us continue with 10.1a today. Okay, so the other day we skipped this part first due to a time constraints because we were running out of time. So today we're going to see how are we going to sketch graph, okay, for a given uh, value, okay, at a given value for a given case. So now let's see. So the graph, okay, now if you look at the learning outcome, learning outcome, discuss the graph of a displacement times and a displacement distance. So we will have two types of graph in chapter 10. Okay, one is a displacement times and another one is a displacement distance. But both of them, they are going to use the same equations. All right, just that how are you going to modify it in order to be used in a graph sketching? So to sketch a graph of displacement against a distance graph, okay, y against x graph, usually you will be given time. So the graph shows the displacements of all particles in the wave at any particular time. So time is given, okay, times is given. So for example, consider the equations of the wave is y equals to a sine omega t plus kx. So this is the general equations. All right, this is the general equations for a mechanical wave, for a wave that is moving, for a progressive wave. So for particles at times t equals to 0, now as you can see here, you are given times t equals to 0. So what are you going to do then? Now, whenever you are given a quantity, a value, okay, basically you just have to substitute it into the equations. So at times t equals to 0, our y is equals to a sine omega times 0 plus kx. So this is what we have to do. You are given times equals to 0, so you sub 0 into the equations. Therefore, we have y equals to a sine kx. Now, isn't it looks very familiar now? Okay, now that you have reached this step, these equations basically is same as the equations that you have seen in chapter 9, the simple harmonic motions. The only difference is rather than sine omega t, now you have sine kx. Okay, so a y sine kx because you're going to sketch a graph of y against x. So now I have a y-axis here, I have x-axis here. So y-axis is still y, and then x-axis now is the x rather than time. Okay, because now we know this whole thing, it happens at times t equals to 0. This is the shape of the graph at the times t equals to 0. Okay, just at one moment. You're not looking at the whole motion right now. You're looking at what happens at one moment, at one given time. So at times t equals to 0, this is the shape of the graph. Okay, so you have a sine graph without initial phase angle. Therefore, the shape would be like this. Okay, just a regular sine graph. And again, since you have the graph, okay, you have the shape already, then you can label the graph. Y against x. So y against x, what we have here, this is still the amplitude. Okay, and then this is the negative amplitude. And since now you have x along the y component, and remember the unit for them, okay, the SI unit is in meter for y and also for x. Y is a displacement. You're looking at the displacements of one particles, and then x is the positions of the particle from equilibrium positions, okay, from the source. So remember, y and x, what is the difference? Y refers to the displacement of a particle from its equilibrium position. X refers to the distance of that particular particle from the source. Okay, if you still remember, we say when in order to generate a progressive wave, we need a source. Okay, maybe you drop a stone into the waters and some things, then it start to transfer energy to the particles beside it. So the whole wave is actually a series of particles that is vibrating. Okay, that is vibrating. So we have a particles that is vibrating. Okay, like I shows you on the right hand side. So all these particles, they are vibrating. So y refers to the, okay, now this is our equilibrium position. So y is the distance from equilibrium position. Okay, so this is your y. And then x is the distance of every single particles from the source. Okay, so this is your x. So for displacement, you're just looking at what happens inside one particles. For x, okay, we have different value for different particles. So x, you have multiple particles, y, you are just looking at one particles. Oops. Okay, so now, okay, let us go back to the graph. So in that case, for x component, okay, we can also determine the wavelength of the graph. Okay, so when you combine them, when you join all these particles with a line, so this x, okay, after one complete oscillation, it will give you the values of lambda, okay, the values of wavelength. So these are the informations that you can get from a y against x graph. So it is very important for you to identify the axis before you solve the questions. Okay, so now why is it important to have a lambda? Well, that is because you can calculate k, the wave number, by using lambda. So k equals to 2 pi over lambda. Okay, or in another words, if you are given the wave number k, then you can use it to determine wavelength. Okay, so that you can use it to plot the graph. You can label it in your graph. Right, so that is for a y against x graph. Now, how about y against t graph? Okay, since we say you can sketch two different graphs in this chapter, one is y against x, another one is y against t. So y against t, it shows the displacements of one particles in the wave at any given distance from the origin. Okay, just now you look at what happens at a given times. Now you look at what happened for one particular particles at a given distance. Okay, so for example, consider the equations of wave. Now you still have the same equations, just that I'm using a negative sign. So for the particles at x equals to 0, okay, so for particle at x equals to 0, the equations of these particles is given by, okay, so you look at what happens to these particles at a different time. Okay, so okay, at particles x equals to 0, you're looking at what happens to the first particle. So now we're going to sketch a graph for y against t. So rather than y against x, why y against t? Okay, because now you're given x equals to 0. So if you sub x equals to 0 into the equations, you are going to obtain y equals to a sine omega t. Okay, particles and equations that you have in chapter 9. Okay, so basically it tells you what happens in just one particle. Now this particle, it actually undergoes simple harmonic motions. Why? Because this one particles, it keeps oscillating up and down. Okay, it keeps oscillating up and down. So you are looking at what happens to this one particles at different time. So at times t equals to 0, the particle is equals to y equals to a sine omega t. So now you have a sine function. So you just sketch the graph. Okay, again, you have a sine graph according to the informations given. Right? So, well, basically, you just have to label the graph like what you did in chapter 9. So you have this one again. I'm going to use SI unit, but of course, most of the times, you won't have SI unit. Okay, you won't have SI unit. So y in meter and time in second. So we have a maximum amplitude here. So this is a negative a. But now because your x-axis is time, therefore after one complete oscillation, the information that you have is period. Okay, is period. So omega t is equals to 2 pi over t. And remember the things that I told you before. This family, they have three members. Okay, there are three members in this family. Omega, period, and one more is the frequency. Okay, so 2 pi f. So this equation is very important. All right. So once you have either one members, then you can use it to calculate the informations needed, either to form equations or either to plot the graph. Right. So for y against x, there are two family in a group, which is k and lambda. For y against t, there are three family in a group, okay, which is omega, period, and frequency. Now, what if you have a time that is not equals to 0, and the questions ask you to sketch a graph. So for a particles at times t equals to 0.25 capital letter T, okay, so how are we going to solve it? So the equations is given by, so now we are going to think, how are we going to solve the equations? Okay, so y is equals to a sine omega t plus kx. This is the general equations. Okay, so now we want to sub the value t. Now t is equals to a non-zero value, so t equals to 0.25 capital letter T. We are not given some values of omega. Okay, in order to plot y against kx graph, we need to think, how are we going to eliminate omega t in our equations? Okay, or how are we going to make it into a known value rather than unknown omega t? So if t equals to 0.25 capital letter T, now try to think, what is the equations of omega? Well, we know omega is equals to 2 pi over capital letter T. Okay, then we sub it into the equations. So the reasons why I sub omega equals to 2 pi over omega t, 2 pi over t, because I want to cancel out the capital letter T in my equations. Okay, I want to change this part into a known value. So if you want to plot y against x graph, omega t must be a known value, right? So now let us continue. So y equals to a sine, okay, omega, we have 2 pi over t times with t is now 0.25 t. So plus kx. So t and t, you can cancel it out. Okay, t and t, you cancel it out. And then we simplify the equations. And we're going to obtain an equations a sine. Now, I want to change the position of these two things. Okay, I want to put the unknown at the front and then put the values at the back. So now I'm going to change it into kx. Okay, kx plus 2 pi. Okay, now it's over 1. Okay, so 0.25 is actually 1 over 4. Okay, so I'm going to simplify it. So y equals to a sine kx plus, okay, 2 pi over 4 becomes pi over 2. Okay, now isn't it look familiar again? Now you have an equations with unknown at the front and then a known value at the back. So this known value, pi over 2, okay, we actually call it a phase shift, all right? Our most usual term actually is incorrect, okay, but to make it easier for you to understand, you can treat it as a initial phase angle, okay, as initial phase angle. But to be more precise, actually we call it phase shift. Okay, so this is a phase shift. Okay, it tells you how it moved already, the graph. Because in this chapter, we are looking at progressive wave, the wave that is moving. So we see how much has it moved. Okay, at times t equals to 0.25 capital letter T when it compared to the initial position, when it compared to t equals to 0. Okay, so now I'm going to sketch a graph. Okay, I'm going to sketch a graph, but now we're going to look at phase shift. So let us begin with a graph without phase shift first. Okay, now I'm going to sketch a graph for without phase shift, without pi over 2. So which means the graph, okay, is just simply a sine graph. Okay, a normal sine graph. So this is y against x. So this is the graph without phase shift. Okay, so this is a graph without phase shift. Okay. So now I want to shift it. Okay, now I have a plus pi over 2 here. I want to shift the graph, right? I want to shift the graph. And actually, if you remember, okay, how we sketch a graph in chapter 9, actually it's very simple. Plus pi over 2, it just simply means that now your graph starts from the maximum value, maximum amplitude, right? Start from a 90 degree. So we are going to shift this y-axis to the right hand side. Okay, we want to shift the y-axis to the right hand side. Therefore, we are going to obtain a new graph. Okay, a new graph that looks like, okay, so now I have a new graph that undergoes phase shift, y against x. So now my graph should start from maximum. So this is how it looks like for the equations. Y equals to a sine kx plus pi over 2. All right, so this is the new graph. So this is the answer. A, and then now at this position, I have lambda. So make sure to always show at least one complete revolutions in your graph. Okay, at least one. Sometimes questions will ask you to give two. Okay, it will ask you to sketch a graph for time for distance 0 until 2 pi, 2 pi plus 2 lambda. Okay, so it means the question is asking for two complete revolutions. Then you have to sketch 2 cycle. But now this one question just asking for the graph at times t equals to 0.25 period. So you just show one cycle is enough. All right. So sometimes questions will ask for more than one cycle, then you have to follow the questions. For example, it's asked you to sketch a graph for 0, okay, and then x until 2 lambda. Then you need to show a graph with 2 complete oscillations. So you need to show a graph like this. Start from maximum, okay, and then one more. So this is for 2 lambda. Okay, so this is a lambda, and then this is 2 lambda. So this is y against x. So anything you have to refer to the questions. See how many revolutions you have to sketch, how many cycles you have to sketch. All right. So initially we do the one without phase shift, and then we shift the axis. Okay, the y-axis. Usually I like to shift the axis. Okay, some lecturer they like to shift the graph. So it's up to you. Okay, it's up to you. You can shift the graph, you can shift the axis. So if you have a positive phase shift, then you move the y-axis to the right-hand side. So if you have a negative phase shift, then you just move the y-axis to the left. All right, so positive, you move it to the right. Negative, you move y-axis to the left. So now let's try it for y against x graph. So again, we are going to start from general equations. Y equals to a sine omega t plus kx. Since now you want to sketch y against t graph, so we need to find out what is the value for kx. We need to transform it into a known value. All right, so now let's see. Given x is equal to 0.25 lambda, and we know k is equal to 2 pi over lambda. So the way to simplify it is the same as the one just now. Oh wait, I have a mistake here because the general equations given in this question is negative kx. Okay, minus. So we are going to see how to solve the one with a minus phase shift. Okay, so now I have the information that I need. I'm going to simplify the equations. So y equals to a sine omega t minus k is 2 pi over lambda times 0.25 lambda. Okay, 0.25 lambda. So cancel out the lambda. I have y equals to a sine omega t minus 2 pi over 1. Again, 0.25 is 1 over 4. Okay, so simplified it again. It is a sine omega t minus pi over 2. So rather than a plus, now you have a negative phase shift. Okay, so again, this part, this is our phase shift. Okay, our phase shift. So now negative means our graph propagates to left-hand side. So it shifts to the left-hand side. Okay, now I'm going to sketch a graph without phase shift first. Okay, without phase shift, I'm going to sketch a graph for y equals to a sine omega t first. Okay, so without phase shift, this is the graph. Right, so this yeah, a bit ugly. Let me redraw it. Okay. Okay. So without phase shift, this is how it looks like, right? So you have a y against t graph here. And next, what am I going to do? I'm going to do with phase shift. Okay, I'm going to move my y-axis to the left-hand side right now because of the negative sign here. All right, so I move it by how much? By pi over 2. Okay, so this would be my new y-axis. And then I'm going to shift it by pi over 2. So what am I going to do? Basically, I just continue the graph. Okay, I just extrapolate. I just draw the graph. I just let it continue. Okay, I just let it continue from the origin. So rather than you move the graph, you add the line. Okay, you add the line before the y-axis. So now my new graph, the graph for y equals to a sine omega t minus pi over 2 would be like this. Okay, so if I extend the graph, then the graph would start from the negative maximum, which makes sense, okay, because now I have negative pi over 2. So now my graph would be an inverted cos function. Okay, so this is my negative a, and then this is my amplitude, and again, this is my, oh, it should be times on the x-axis, all right? Because now I'm sketching a y against t graph. So now I have this one is a period, capital letter T. Done. Okay, so done. This is how we do a phase shift. Positive, you shift the y-axis to the right. Negative, you shift it to the left. Okay, you shift it to the left. So after you shift it, then you just complete the graph. Okay, you just extend the line, or you just throw the lines that you don't need, like the one in the positive phase shift. Okay, like the one here. So because now I move my y-axis to the right-hand side, therefore I remove the line before a y-axis. Okay, so I remove the line. I cancel, oops. Okay, I remove the line here. So I cancel the line here. I remove it. So I let my graph start from maximum. And then I complete it. Okay, I extend the line at the back so that it becomes one complete cycle. Okay, so it becomes one complete cycle. So that is the difference between positive phase shift and negative phase shift. Okay, so now I will give you some time to write it down. You try to understand it. Okay, you try to write it down. If there's anything that you don't understand, make sure to ask now. Yeah, okay. So you can zoom in your handphone or in your laptop, all right, so that you can see what is going on. So I will leave this page on a screen for another 5 minutes. Okay, so these 5 minutes, you try to complete this page. You try to understand everything's here. You try to see how to do a phase shift, how to shift your graph to the right, how to shift the graph to the left. Okay, how to do it when you have positive phase shift, when you have a negative phase shift. Right. So 5 minutes for you to complete this page. If you have any questions, then you may ask. Wow, good. No questions. Everyone understand how to do phase shift, how to shift the graph. Okay, so I give you a bit more time to complete it. This is very important, right?
Madam, nak tanya,
Yes?
for the distance against time,
Yeah?
so the general equation must be minus lah. No,
No,
not
not
positive.
necessary. Dia
Oh, not
terpulang pada soalan.
oh, okay.
And sometimes questions will ask you to form the graph, okay, to form the equation, sorry. Then you yourself have to know whether to use positive or a negative sign. Because questions will tell you now your graph propagates to the left or propagates to the right. So from there, you then determine whether it should be positive or negative. Okay, whether it should be positive or negative. So if you go back to the definition, okay, you go back to the definitions of a graph. Okay, let us go back to the previous page. Okay, so if you go back to the previous page, I think you have discussed it before. So, where is it? General equations, yeah. So if you look at here, the directions of the wave propagations. So if you have a negative sign, then it means your object is moving to the right-hand side, the whole wave. So negative means this wave is propagating. The whole wave, it keeps moving to the right-hand side. If you have a positive, then it means the wave is traveling to the left. Okay, it's going to the left. So from there, you yourself determines whether you're going to use positive or negative in the equations. And then baru kita buat, okay, and then we proceed to the sketching the graph. Alright? So itu beza dia. Positif, negatif, dia memang terpulang pada soalan. Whether your graph is now propagating to the right or propagating to the left. Okay, so ini, I think that's the most complicated things for today class. So next we're going to do something simple. Okay, so I will use 1 more hour for chapter 10. Okay, so maybe we got to do a class ganti or an extra class after this. Right, because I want you to understand before I move on to the next subtopic. That's why it takes a bit more times compared to the times allocated to this chapter. So by right, this chapter I should finish it within 1.5 hours, but I think we're going to take 3 hours to discuss the whole chapter. So which means we will need an extra class maybe next week, okay, or maybe this weekend. So well, that one we'll leave it first. Okay, now let us look at this 10.2. So 10.2 state the principle of a superpositions of wave for constructive and destructive interference. So principle of superpositions, what does it mean? It means when you have two or more waves, they move through a medium, the displacements of the mediums are equals to the sum of the wave. So if you look at the examples given, now you have a wave coming from left and a one coming from the right. Okay, so what happens when two of them, they meet each other, they overlapping with each other. So for example, initially you have this one, let's say you have a 10 cm. Okay, you have 10 meter, for example. And then this one is 5. So when they're overlapping with each other, the total will become 15. So every point that they overlap with each other, so the displacement, they add up. Okay, they add up. So they will just keep moving, and then after that, they will move towards opposite direction. So both waves, they keep moving. The one traveling to the right will keep traveling to the right. The one going to the left will keep going to the left. right? So that is the meanings of a superpositions, principle of superpositions. They are overlapping, so you add them up. So because of this principle of superpositions, then we have a interference of two waves. So interference is defined as the interactions of a two or more wave motion. And now we have constructive interference and destructive interference. What does it mean by constructive interference? Constructive, okay, means that now your resultant displacement is greater than the maximum displacement before they overlapping with each other, okay, before they superimpose with each other. So a constructive interference, the resultant displacement is greater than the displacements of individual wave. So individual wave, initially the amplitude is just A. Okay, this is the equilibrium line. So amplitude is A. So when two of them, they overlap with each other, they give you 2A. So this is what we call constructive interference, because the product, okay, the product of a superposition is larger than individual wave before they undergo superposition. So it occurs when y1 and y2 have the same wavelength. Now, this is the conditions that you must memorize. And usually they like to ask this one in objective questions. Okay, it occurs when y1 and y2 have the same wavelength, same frequency, and they are in phase. Okay, so each other, whether change in the phase difference between them is 0, 2 pi, 4 pi, 6 pi, and 8 pi, and so on. Okay, so if they are in phase and then they overlap each other, they have the same wavelength, they have the same frequency, then they give you constructive interference. Whereas destructive interference means that the result is less than individual waves. Okay, so the resultant displacement is less than the displacement of the individual wave. Okay, so when you have A here, and then the other one you also have A, but now they are anti-phase. Okay, anti-phase means now they are moving towards opposite direction. So then they will experience cancellation. So if they have same amplitude, then it will experience total cancellation as shown in the diagram here. Okay, this is a total cancellation. All right, total cancellations. A. So A and A, they cancel with each other. Now, of course, this one happens because they have same amplitude, right? If they have different amplitude, of course, you will still have a amplitude in a resultant wave, right? This one is a total cancellation just because they have a same amplitude. These two wave, okay, these two antiphase wave, they have same amplitude, so they experience total cancellation. So basically, that is our destructive interference. So we have constructive, we have destructive. Now, what are we going to see? We're going to see what happened if you have a series of waves. Just now, we are looking at one particular moment. Okay, we're looking at a one moment where when two waves they are totally okay, they are in phase, or when two waves they are anti-phase with each other. Now we want to see what happens if you have two waves that keeps traveling, okay, that keep moving, that they are not stopping at any particular moment. Okay, they just keep moving, without stopping. So previously in the first subtopic, we were looking at progressive wave, right? So now what are we going to do? We're going to see if we have two progressive wave, one coming from the left-hand side and one coming from the right-hand side. What happened when they overlap with each other? Okay, when they meet each other. Okay, now let's see. Define, okay, now stationary wave is defined as a form of a wave whose profile do not move and no energy is transferred from one end of the medium to the other end. So the wave seems like it is not moving. Okay, seems like it is static. It's a freeze. Okay, tak bergerak, dia stay sahaja. Okay, now stationary wave is formed when two wave, okay, two progressive wave to be more precise. Okay, when two progressive wave with same speed, this is the condition to obtain stationary wave, same speed, same frequency, same amplitude, and traveling in the opposite direction. So in order to obtain stationary wave, these are the conditions. So as shown in the diagram, now you have a progressive wave coming from the left-hand side. So the one coming from the left-hand side traveling to the right, the equation is y equals to, I'm going to use small a here, okay? A sine omega t minus kx. This is when my wave traveling to the right. And then for the other one is y equals to a sine omega t plus kx because of the directions. Now the wave is traveling to the left, right? Wait. So this negative sign, it means travel to the right. And then this positive sign, it means travel to the left. Okay, the wave is moving to the left. So this answer the question that you asked me just now. When to use positive and when to use negative? You look at the directions of the propagation. And at one moment, two of them, they will overlap with each other, and then they give you this one. Okay, they give you this one. Where the total, okay, where the graph, it seems like it is not moving right now. It seems like it stays static. So actually, this one is one of the experiment. I think it's your experiment 6, if I'm not mistaken. So you can watch the video and see what is the product. You will see a wave that looks like it is not moving. Okay, they give you a shape like this, as if the wave is not moving. It just keeps oscillating at its position. All right, it's just like fixed. Okay, so this is what you're going to get if you have two progressive waves overlapping with each other. So you try to watch the video, you will see the graph, it looks like this. Okay, the wave, it looks like this, right? So by considering the wave functions for two progressive waves, so this is what I show you in the diagram. You have one negative and one positive. And according to the principle of superpositions, the total displacement of the standing wave is equal to the displacement of first wave plus the displacement of the second wave. Okay, so you do the expansions of the equations, and eventually you obtain an equations y equals to 2a sine omega t cos kx. Okay, 2a sine omega t cos kx. So the things that you should put in the box. Let me find it. Okay, so after you expand it, the equations that you will put in the box, okay, is y equals to a sine omega t cos kx. But you have to be extra careful, okay? You have to be extra careful. When it comes to this stationary wave, you have two different A, where capital letter A is the amplitude of stationary wave and small letter A is the amplitude of progressive wave. And quite often, questions will give you the equations of progressive wave, and then it asks you to form equations for stationary wave. So in this case, you have to know that capital letter A is actually equals to 2 small letter a. Okay, so this is our equations for stationary wave. All right, so we obtain these equations through derivations, through the additions of the displacement of two progressive wave. All right, so y equals to y1 plus y2, then you apply trigo identity until you obtain y equals to 2a sine omega t cos kx. So from there, you then change the 2a into capital letter A. So capital letter A is equals to 2 small letter a. All right, 2 small letter a. So make sure you don't get confused between progressive wave and stationary wave. Okay, so this is the equations for progressive. Progressive means the wave that is moving. And then this is the one for the standing wave or stationary wave. Okay, the wave that looks like it is just standing there without moving. That's why we call it standing wave. All right, so make sure you know the difference in the equations, because quite often the questions will ask you to transform the equations from one to the other one. Okay, now there are 3 types of amplitude that we use in describing stationary wave. So first, you have small letter a. Okay, you have small letter a, where we call the amplitudes of the individual wave. And then we have the amplitudes of a stationary wave and the amplitudes of the simple harmonic motions of the particles. So you have three different amplitude here. Okay, so this two, okay, is the amplitude of the wave. This one is the amplitude of a particle. Aha. Okay, amplitudes of the particle. So make sure you use the right equations. So the amplitudes of the particles, how are we going to do it? Now, because we have equations, y equals to a sine omega t cos kx. Okay, y equals to a sine omega t cos kx. Now, if you look at the particles, it tells you the amplitudes of simple harmonic motion. Okay, amplitudes of a simple harmonic motions of a particles. So what are we going to do? We rearrange the equations. So y equals to a cos kx sine omega t. Then you compare with general equations in simple harmonic motions, where the general equation is y equals to a sine omega t. This is from simple harmonic motion. Okay, any general equations are a simple harmonic motion. SHM, in which it tells you, okay, it tells you this whole part is actually the amplitude of particle. Okay, amplitude of particles. Okay, because it represents the A here, the A in simple harmonic motions. So don't get confused between three different amplitude. The A in stationary wave, this one just represents the amplitude of stationary wave. Okay, and then the A in a progressive wave, that one is a different story. And when you compare these stationary wave equations with simple harmonic equations, you'll see that A cos kx, this whole term, this whole part, it represents the amplitude in simple harmonic motions. And simple harmonic motion, we use it to describe the motions of particle. Therefore, we say A cos kx is the amplitude of particle. Okay, we use simple harmonic motion to describe what happens to particles in stationary wave, what happens to particles in a stationary wave. Therefore, when you compare these two equations, you will see that A cos kx is actually the amplitude of particles. Right? So tiga jenis amplitude, faham kan? What is the difference between them? So even though they are all using capital letter A, but capital letter A in different equation, it carries different meaning. Okay, capital letter A in different equations, it carries different meaning. Okay, so done. Okay, so I give you 2 minutes to digest what is the difference between these three amplitude. Of course, you can write it down. You can make a notes in your books, okay, in your handout. Bagi kamu 2 minit untuk digest sedikit apa yang sedang berlaku di sini. Okay, apa yang sedang berlaku di sini. Okay, so kalau ada part yang mana yang tak faham, pastikan Anda tanya. Make sure you don't get confused. So chapter 10 is a bit confusing. Why? Because you're looking at two different waves, and some more you have to add in simple harmonic motions, okay, for the particles inside the wave. So remember, wave is being constructed by a series of particles. So when you combine all of them into one line, then we obtain a wave. But if you are going to look at each individual particles, then we'll use simple harmonic motion to describe the motion, right? Because the particles is oscillating in a wave. So it's a periodic motion. Okay, it's a periodic motions. All right, so let us move to the next part. So this is a graph of a standing wave. So graph of a displacement distance, when it comes to a standing wave, this is the graph that we use. So we have an antinode. Antinode is the maximum position. Nodes is the place where it experiences total cancellation. So nodes, antinodes, and so on. So you will see the distance between antinode and node is a lambda over 4. Okay, so the distance between nodes and nodes is lambda over 2. Okay, lambda over 2 and lambda over 4. All right, so every other distance, they are always the same. So node is the point of zero displacement. Antinode is the point of maximum displacement. Distance between two successive antinode, okay, is a lambda over 2, or distance between two successive node, okay, and distance between two successive antinode and nodes is a lambda over 4. Okay, so basically this one is anti and then anti. And then this one is a nodes and a nodes. Okay, the distance between these two particles, these two positions. Whereas for lambda over 4, you're looking at the distance between anti and also the nodes. All right, so that is the difference between them. Okay, so done. Okay, I'm not going to spend too much time on there. I'm going to focus more on this one, the table. All right, the table. So in tutorial, you will see how to use stationary wave equations, okay, because you need to find the position for nodes and antinodes. So in lecture, I'm not going to discuss that one, all right? But I will give you the videos in chapter 10 where it covers everything, including the things that you need to know in tutorial, okay? Don't worry. Okay, now let's go to this table. Okay, this table, it sums up everything in 10.1 and 10.2. It tells you the difference between progressive wave and a stationary wave. Progressive wave, it moves. All right, the whole wave profile means the line, it keeps moving. And then for stationary wave, the wave profile, it does not move. Okay, it does not move. And then the progressive wave, all particles vibrate with same amplitude. Aha, what does it mean? Why for stationary wave, they are all vibrate with different amplitude? So since progressive wave, like I told you, the wave, it keeps moving. Okay, first moment, second moment, maybe the wave is already like this, and then it keeps moving on, okay, until like this. So the wave, it keeps changing. That is our progressive wave. So the wave, okay, the particles, the position, it keeps moving, which means every particles along a progressive wave, okay, for example, now I'm going to sketch a progressive wave like this. So every particles, they will keep oscillating at the same amplitude. So let's say this is your amplitude, okay, this is your A, this is your negative A. Every particles, they will oscillate in between these two distance. Okay, they will oscillate in between two distance. But when it comes to stationary wave, because the wave is not moving, so if you have a wave that looks like this, then the amplitude is fixed. Okay, the amplitude is fixed. So this is our equilibrium position. Okay, so every particles, they have their fixed amplitude. They won't change anymore. Okay, they won't change anymore. Therefore, every particles in stationary wave, okay, between two adjacent node, okay, so this is our node, and then this is a node, okay. So every particle in between node, they have different amplitude, okay, because of what? Because they are not moving. They are unlike your progressive wave. Progressive wave, every particle is oscillating, okay. Every particle will have a chance to reach amplitude, to reach negative amplitude. They keep vibrating. But when it comes to stationary wave, they are not vibrating, okay? What you have is just a fixed amplitude. So that is the maximum distance that can be traveled by every particle. They won't change anymore. They won't move to other distance. They won't change the amplitude, okay? So that is the meanings of the second statement. Okay, in progressive wave, they all have same amplitude. In stationary wave, they all have a different amplitude. Progressive wave neighboring particle vibrate with different phase. Okay, different phase. And then when it comes to stationary wave, okay, stationary wave, they all vibrate in phase. Now, what does it mean? If you look at progressive wave, because the particle, it keeps oscillating up and down, so the angles keep changing. Okay, the angles keep changing from 0 maybe to pi over 2, and then to 2 pi, and then it goes back to pi over 2 and go back to 0. But for stationary wave, the particles will stick to its maximum amplitude. Okay, it won't vibrate actually. Okay, it won't go to all the other angle. It will always stick to maximum angle, 90 degree. So they are always in phase. So every particles along stationary wave, okay, this is pi over 2, and then this one also pi over 2 right now, pi over 2 right now, pi over 2 right now, pi over 2 right now. So they are at its maximum amplitude. They are all at its maximum position from equilibrium position. When it comes to progressive, not necessary. Okay, the first one is a 0 degree, and then maybe this one is a pi over 4. Maximum amplitude is pi over 2, and then it goes back to pi over 4, and then it goes back to a negative pi over 2. It goes back to 0 first, and then it goes to the negative pi over 2, negative pi over 4, and so on. Okay, so progressive wave, they have different phase. Okay, they move with different phases. When it comes to stationary wave, they are always in phase because they always travel to its maximum displacement, to its amplitude. Okay, to its amplitude. So in progressive wave, all particles, they vibrate. Okay, all particles vibrate. In a stationary wave, they seems that they do not vibrate at all. That's why you have a fixed amplitude. Okay, that's why you have a same phase. And then progressive wave is produced by the disturbance in elastic medium. So you drop something into waters and then it start to generate wave. You need a source, okay? You need a disturbance, which means a source to initiate the progressive wave. And then when it comes to stationary wave, it's a superposition of two waves that is moving in the opposite direction with the same frequency, same speed, and so on, right? And then progressive wave, because the wave profile is moving, so it transmits energy. For stationary wave, because it's not moving, so it cannot transmit energy. So it does not transmit energy, right? So the most important things that I want to explain is actually the second and the third one, because usually these two students don't understand the meaning of these two statements, right? So now I'm done explaining. I hope you understand. Right. So I think, yes, that's it. Okay, so we are done with 10.2. So next class, okay, I think I might do extra class with you guys. Okay, if yes, probably this Saturday, maybe 11 a.m. If no, maybe on Monday night. Okay, so I will do a poll in the group later on. You guys try to select whether you prefer Saturday or you prefer Monday. If Monday is at night, Saturday means 11 a.m. Right? So I think that's all for today class. So you may leave the class now. Okay, you may leave the class now.
Thank you.